It's hot. I think it's even hotter here.
We're out in New York City investigating a big problem that's hiding in plain sight. It's hot. Too hot. And not just because it's summertime.
Cities everywhere, not just New York, are basically running fevers. They're up to 22 degrees Fahrenheit hotter than surrounding rural areas. It's a phenomenon called the urban heat island effect, and it has serious consequences for cities and their residents. That's actually horrifying. So we'll take a reading on the asphalt.
Surface temperatures are hotter here in New York City than they are in nearby Woodstock and other parts of the Hudson Valley. This map, generated from satellites, shows us that New York City is an urban heat island. You'll notice that New York and nearby urban areas look like orange islands in a sea of green. So, what makes cities on the map so much hotter than other areas? Well, we built our cities in a way that traps heat. Dark, impervious surfaces on streets and buildings are really good at absorbing radiation from the sun during the day and holding it in. Buildings also form urban canyons, which trap heat and block the natural airflow that might otherwise cool a city down. Cars, trucks, factories, and power plants all release heat when they're running, and their pollution can form a haze over the city that causes a mini greenhouse gas effect that stops heat from escaping. Urban jungles also have fewer trees to provide shade and fewer plants to keep things cool.
Okay, so here on the sanitation department parking lot that's just covered in black asphalt, the ground is registering at 110 degrees Fahrenheit. That's really hot.
Taking readings like this is one way to make sure that what the satellites see matches up with what's actually happening on the ground, while also spotting things that satellites can't detect from so far away. It's what scientists call ground truthing.
Is that satellite picking up the same thing that we're seeing at the ground level? And with the precision that goes into building all these things, yes, for the most part, these satellites are very accurate.
That's Elizabeth Sebastian. She developed a curriculum with NASA to teach students about urban heat islands. She taught us how to measure surface temperatures using handheld thermal cameras, so we can better understand heat islands that the satellites pick up.
The reason why we want to use microside things is to see those little pockets of heat that are not going to be captured by the satellite. I want to see, well, where is it coming from exactly? It could be a heat duct that's being let out from a building, or it could be something underground. So it helps to kind of investigate a little bit further on those really small scale things.
In cities, those little pockets of heat can really add up and even be deadly.
Over the past 3 decades, extreme heat has killed more people on average each year than any other weather-related disaster in the US. And this pain isn't felt evenly. In New York City between 2000 and 2012, African Americans made up about a quarter of the city's population, but nearly half of its heat-related deaths.
That's part of a legacy of environmental racism. Some spots in the city are actually hotter than others. Where we are in East Harlem is one of them.
Yeah, so we're coming up on a really hot corner of East Harlem. This is one of the areas where you find really, really high temperatures on a very hot day.
Yeah.
Sonal Jessel took us on a tour of some of the hottest parts of the neighborhood.
In New York City, the Heat Vulnerability Index, which tells you sort of on a scale of 1 to 5 how hot a neighborhood is or sort of its heat risk, East Harlem is a 5. It's because of a combination of built environment and socioeconomic factors. In terms of built environment, we have that lack of green space, major highways and sources of air pollution.
Another map might be able to show us how this happened. Starting in the 1930s, financial institutions denied loans and home insurance to people living in red-lined neighborhoods. These places were deemed hazardous, often for having Black residents or other people of color. And over time, the neighborhoods received less investment for things like parks. Instead, land was allotted for roadways and industrial development.
Because of redlining, there was also a lack of investment in sort of economic vitality and businesses and housing. And over a long period of time, over many decades, you see that that investment has not come back into the community in the way that it was deserved.
After decades of systemic racism, a person of color in the US, on average, lives in a census tract that's nearly 2 degrees Fahrenheit hotter in the summer than someone who is non-Hispanic white. And formerly redlined neighborhoods are up to 12 degrees Fahrenheit hotter than other neighborhoods.
We're on this lovely, nicely shaded street in the Upper East Side. Pretty fancy neighborhood in New York City.
Just a few blocks away on the Upper East Side, it's a different story.
Right here on the sidewalk, that's a lot cooler than where we were just at. There are more trees and parks, and that makes this neighborhood less vulnerable to extreme heat than East Harlem. I mean, this is a cooler street. I can feel it. It's nice and pleasant on this street, not too hot.
Even on a sunny corner at a busy intersection, we found that the surface temperatures could be close to 25 degrees cooler than in nearby Harlem.
But our reading here on the black asphalt in the middle of the street, which should be really hot, is still significantly lower than where we were at in East Harlem earlier.
So what can be done to cool East Harlem down? Sonal has some ideas.
Yeah, so the city has a good outline for what they want to do, and they have done some really good things. Really what we want to see is just more of it.
New York has planted 6,000 more trees since 2018, and it's painted 10 million square feet of rooftops white so that they reflect heat instead of absorbing it.
We also need the city to be doing more around investing in sustainable cooling options for people's homes, making sure people have cooling systems in their homes, making sure lower income housing that's been poorly maintained gets the maintenance it needs to be more efficient and better weatherized. All of that needs to happen in just a bigger way than the city is doing yet.
Researchers are using satellite remote sensing to track progress that cities like New York are making to counter the urban heat island effect. Reggie Blake and Hamid Nourouzi are doing just that.
One of the research activities that we are working on is to quantify that how effective these mitigation efforts are. In other words, we know that trees are helpful to lower urban heat island, but how much adding, one tree to a street will help to lower that, urban heat?
Not only are we looking at these adaptation measures and seeing how effective they have been, but also to use the latest technology, the same things we've been using, satellites, to help us to understand how impactful these trees have been.
Measuring that progress will only become more important as climate change makes the urban heat island effect worse.
One study estimates that there are already around 600 heat-related deaths in New York City each year. By 2080, that could climb up to 3,300 deaths annually if nothing is done to tackle climate change. While it doesn't solve the climate crisis, better data can still be a tool for people in heat-vulnerable communities to move the pendulum in the other direction.
I think it's important to understand the impacts that these studies have on the community, and how important it is to empower local residents to become part of the revolution of understanding what's happening in their neighborhoods, so they become part of the solution and not part of the problem.
Well, we built them in a way that traps heat. Like yelling. We're out here.
It's like we're in a heat vortex.